So when it comes to multiplying matrices, there's a couple of concepts we're actually going to have to cover. First of all, we're going to have to ask the question, how do we even do it? The second question that we're going to ask is, does the commutative property hold? If you forgot what the commutative property, that's okay. What the commutative property is, we will come back to that. And then the final thing is, so there's the how do we do this? There's some other properties here, but then when does it actually work? You'll find you can't actually multiply all matrices together. So the first question we're going to answer is, how do we do this? So here's the best way to show it. We're actually going to go straight into an example. And I'm going to try to make the example a little bit simpler and use some slightly smaller matrices so that we really focus on what's going on rather than getting all mixed up in the convoluted math. So let's let, I already had A, B, and C in the previous video, so we're going to do two new matrices. We're going to have matrix D is 5, -2, -3, 1. And we're going to have matrix E, which is -2, 1, -4, 3. So notice both of these matrices are 2 by 2. And actually, just to kind of review one of the other vocab words, they're both square matrices because the number of rows equals the number of columns. Okay, so here we go. Let's get straight into an example of how to multiply these matrices. So we'll do D times E to start with. So first of all, let's just go ahead and write them next to each other. 5, -2, -3, 1 times -2, 1, -4, 3. Okay, so we've lined them up. Now we're going to multiply them. But the question is, do I take 5 times the -2, or do I, for some reason, multiply by the -4? Where's the 1 and the 3 go? So the question becomes, where do all these numbers end up going? How do we multiply these? And it's been decided that the way we multiply is we take each row and then multiply it by each column. So we're going to be doing row 1 times column 1. And then we're going to do, and I'll explain a little bit more because it still doesn't really make sense if you go component by component. But then I'm going to do row 1 times column 2. And then I'm going to do row 2 times column 1. And then I'm going to do row 2 times column 2. And when this is all said and done, I've sort of written this in a manner that should be making you think about a new matrix. It's actually is going to be a matrix that looks like this. And if I were to call this matrix M, notice that row 1, column 1 will become my M1, 1. It's the term in this new matrix M that is in the first row in the first column. This one's going to be my M12 term, my M21 term, and my M22 term. So if we were to say that after I multiply the matrices, this equals some new matrix M, here's how we're going to find those different components of M. M will be a 2 by 2. As you can see, I'm going to have row 1, column 1, row 1, etc. And I'm going to have a total of 4 terms, and they're going to be arranged in such a way as to be a 2 by 2 matrix. Okay, so let's go into how this multiplication actually works. So let's start with row 1, column 1. So taking a quick peek up here, row 1 is the 5, -2, and then column 1 on the other matrix is -2 and -4. So what I'm going to do is I sort of line up these terms. The 5 and the -2 are going to go together, and then the -2 and the -4 are going to go together. And this might be somewhat reminiscent of the dot product because we're going to multiply those terms. I'm going to do 5 times negative 2, and then I'm going to add negative 2 times negative 4. Just like in the dot product, you multiply the matching components and then you add the two together. So when I do this, I end up with negative 10 plus 8, so I end up with a negative 2. Another way I kind of like to think about it is I actually take row 1 and I sort of flip it around so that it looks like this, 5, negative 2, and then I put it next to the other column, negative 4, and then I can see that I just have to multiply those and then add them up. So that's another way to do it. I kind of, in my mind mentally, I sort of rotate the row to be a column, and then I just sort of mash them together. So this is another option for how to think about this. So then let's go ahead and look at row 1, column 2 now. I still have row 1, so it's 5, negative 2, but column 2 is 1, 3. So if I were kind of mashing these together, negative 2 and then 1, 3, I put a fraction in there. There's no fraction. Okay. And so then multiplying, we end up with 5 times 1 plus negative 2 times 3. So I end up with 5 minus 6, so I get negative 1. For row 2, column 1, I end up with negative 3 times negative 2 plus 1 times negative 4, because my second row is negative 3, 1, and my first column is negative 2, negative 4. So this ends up giving me 6 minus 4, which is positive 2. And then in the final position, row 2, column 2, I end up with, it's negative 3, 1, 1, 3. So I get negative 3 times 1 plus 1 times 3, which actually comes out to just 0. So going back to my sort of my M matrix here, this would be the first row of the first column because it's 1, 1. This one is going to be the first row in the second column, etc. So my final answer when I did D times E is going to be, putting it all together, negative 2, negative 1, 2, 0. And that's how you multiply matrices. Let's try another one. Let's go back the other way now, and let's say we're going to multiply E times D. So that means I'm taking my matrix E. Let me go back to that. Negative 2, 1, and then negative 4, 3, times my matrix D, which is 5, negative 2, negative 3, 1. And so in the very first position, I'm going to have negative 2 times 5 plus 1 times negative 3, which would give me negative 13. In the next position, I'm going to have negative 2 times negative 2 plus 1 times 1, which is going to give me 5. Notice I'm doing 1, 1 here, 1, 2. And now for 2, 1, I'm going to have negative 4 times 5 plus 3 times negative 3, which will give me negative 29. And then for the final position, I'm going to have negative 4 times negative 2 plus 3 times 1. And this is going to equal negative 8. So negative, oh wait, 8 plus 3 would be 11, sorry. Okay. And so that is how you multiply two matrices together. In the next video, we'll talk a little bit more about the commutative property and then when you can actually